Okay, so now we're doing question number 12. A sphere of mass m hangs from two strings that each make an angle of 30 degrees with the horizontal from above. As shown in the figure above, what is the tension T in one of the strings? So first, let's draw a free body diagram of the object. We have two tensions, each are the same, to the strings, and we have a downwards mg. We can break this up into our x and y components, so we still have our downwards mg, but now we can break up our tension into a y component, which is T times sine of 30 degrees, and an x component, T times cosine of 30 degrees. So we can then use Newton's second law and the sum of the forces in the y direction. So the sum of the forces in the y direction is equal to, since we have two tensions that are the same, they both have that upwards T sine of 30 degrees tension force. And so that means we have a upward force of 2 times T sine of 30 degrees, and then it's minus mg, the downward force, and that is equal to 0 because we have no acceleration. What we can then do with that is we can say, because 2 times T sine of 30 degrees minus mg is equal to 0, that means that 2 sine of 30 degrees is equal to mg. Since sine of 30 degrees happens to equal 1/2, that cancels out with the 2, meaning T, tension, is just equal to mg. So the reason we don't really use the horizontal component of the tension force here is because we don't the question 12 is asking for the answer in terms of mg. It asks for answers such as mg divided by 6, divided by 4, divided by 2, 3 times mg divided by 2, and mg. And the answer is mg. This is based on Newton's second law, which states that the sum of the forces is equal to mass times acceleration. Since the ball is hanging there stationary, that's how we know that 2t sine of 30 degrees minus mass times gravity is equal to 0, because we have the mass of our ball times acceleration, which is 0, which makes all of it 0. And then algebraically, that allows us to pull the gravitational force to the other side and isolate T, or simplify so that we have T isolated.